So you probably want to learn to code but aren't quite sure where to begin. Well, before you get started, there are a few things you might want to be familiar with. Welcome to Behind the Keyboard. I am the loose nut, Adam, and this is BTK Lesson 1, Bits, Bytes, and Data Types. In these videos, I'll be using C++, but the basic concept here will translate well to just about any language you choose to code in. What are bits and bytes? Well, a bit is the smallest unit of storage that a computer can hold. It's a bit. It's either a 0 or a 1 in binary. So the binary sentence 010 is 3 bits of information. Now on the other hand, a byte, 1 byte, is going to be 8 bits. Sometimes it can be a little bit confusing. What's bigger, a bit or a byte? Well, think of this. I'm taking a byte of bits. So if I take a byte of bits, I'm going to have more of them in my mouth. Now, this binary sentence, 1001, 1000, it's 8 bits, and we know this because we can count all of the ones and zeros there, and there's 8 of them. 1 byte can store a singular character value, like A, B, C, exclamation point. You get the idea. So what do I mean when I mean data types? What are data types? Well, data types contain data. So we're talking about an integer, a character, a boolean, floating point, double floating point, void. These are the primitive ones. Now there are other ones like longs, shorts, so forth. You're not going to really need to worry about those right now, especially when you're beginning. You'll pick them up later on as you start developing a little bit more skill and understanding. But these are all variables. You look at an integer is actually the variable int, int. Now it's 4 bytes in size, and it has to be a whole number. Now you can look on this graph here and you can see it's a pretty big whole number, either negative or positive. Now a character, or the variable, would be a char or a char, depending on how you want to pronounce it. I've heard both. Either way is fine. It's going to be 1 byte. It's going to be a single character between negative 128 to 127, or 0 to 255. Now what do I mean by that? Well, there's these little tables that tell us exactly what the character is going to actually be in numbers. Don't worry about that right now. Just they're A, B, C, D, just what's on your keyboard. Now what's a boolean? Well, the variable for that is bool, and what are we talking about? True, false. It's going to be 1 byte. We don't always, depending on the language, we don't always type true or false. Sometimes if we want something to be true or false, we need to type a 0 or anything larger than a 0. One will be true and the other one will be false. Now, false is going to be 0. Now, if we want it to be true, it's going to be any number other than 0. But usually we just say it's a 1. Now, for a floating point, what is a floating point? That's kind of a weird thing to say, floating point. Well, think about it. It's a fractional number. We're talking about decimals here. A decimal point is a floating point number. Now, these floating points that we use, they're 4 bytes, which means that gives us up to 7 decimal digits after the decimal. Now, like it is a double floating point, or we call this a double. This is when we need even more decimal point numbers. This is 8 bytes, and we can have up to 15 digits after the decimal point on this. Now, the bottom one here is void. Don't really need to use this when we're coding other than when we're dealing with return types. And this just means 0, nothing, void. It's not going to return anything. Okay, so this is my IDE. This is my integrated development environment. This allows me to code. You may have this. This is Visual Studio's 2019, or you may have something completely different. It doesn't really matter what you use. If you don't have this, you can practice code in any text document you'd like. The first thing we're going to want to talk about is declaring our primitives. Okay, so first we're going to talk about integer or int. Well, how do we declare that? Well, easy. We just type int. Now, all of our primitive types, all of our data types, we need to name them. What can we name them? Well, we can name them whatever we want. Like I can name this Yoda if I wanted to and set them equal to 0. Right? We can do that and it would work just fine. But for simplicity, let's just call this int I. So we'll use I. Now, I can just leave the I like this now and it's uninitialized, but the problem is we don't know what is in that container. It's going to be a bunch of random nonsense from a random place in memory, and we don't want that. Now, if we try to print that out, well, first of all, if you got a good IDE like this one, it's going to yell at you and it's going to not want to compile for you. However, sometimes that's not the case. So what we want to do is we want to go ahead and we want to give this an initial value. So let's give this a 0. Okay. And it can be any whole number. Now, we're going to talk about Char or Char, however you want to pronounce that. There's something in particular that's special about this. Let me show you. Okay, so CHAR is how we go ahead and name this or declare this. And we want to give it a name too. We can call it Luke Skywalker, right? If I can spell it correct, just like the other one. However, let's just go with C, okay? And the same thing goes with this. You want to go ahead and give it an initial value of some sort. So what do we want to give this? Well, first of all, you need to know that I can't just do that. That's not going to work. So you gave that red squiggly. I need to put parentheses, usually single quote parentheses like this, or I'm sorry, quotations, not parentheses. I want to put parentheses around this. Single or double will work. Usually you just see single. And we're going to go ahead and give it an A. But we can put a B. We can put a C, even a symbol if we want. We can actually even put a number, and we just evaluate it as a car or character. So that's what we're going to do. We're going to go ahead and put this as A. And then we want our semicolon. Now for our Boolean, remember bools, they're true or false. Okay, so we'll do a little test on this. We're going to go bool, call it B, and then we're going to see what do you think false would give us when we go to print this out. Think about that for a minute, and then we'll see. Now we're going to look at our float. Same thing, F-L-O-A-T. Call this F, and this needs to be a decimal point. What happens if we go 0.00? Now remember, I can have up to 7 numbers after the decimal point. Okay, I'll let you think about that for a second. Now double D, we're going to do the same thing here. Actually, let's do 1.001. All right, now let's try printing these out first. We're going to do this one at a time. We're going to use the cout statement. Now, cout just is console out. I'm sorry, let me get the typo out of there. So console out. And what are we going to do? We're going to put our variable name right here, I want to see what that int has. Is it what we expect? 0. Is that what we put in there? Indeed, that is what we put in there. Now, what about our car? C. See, these match? A. That is indeed what we put in there. Okay, what do you think the bool is going to print out? It's going to print out false? Let's see. No, it printed out 0. Okay, 0 is false. 1 or any other number is determined to be true. Okay, I'll show you. Let's go ahead and turn this back to true. Compile it. See 1. There we go. Now our float. What is going to happen here? Not what you expect. 0. Well, how come it's not 0.00? Well, it's because it cut everything off, didn't it? It rounded it up on us. But we can fix that. Let's put a number here. There we go. Will it show it or will it cut it off? It showed it. However, it only showed it to a certain amount of precision, and the reason why is because we have to actually set the precision down here. So I'm going to get rid of this statement, uncomment this line. All right, now let's see what it's going to give us for our double D. We need to say D right there, so it tells us 1001. What do you think is going to happen? Is it going to print that out for us? Oh. Yes, it did, and then it added some. It went all the way to the 15s. Now, I suggest you can just play around a little bit with your containers or your variables a little bit and just add different things and experiment and see what actually happens. And when you're trying to print it to your console, you can use cout. But if you use cout, you need to have this right here using namespace standard. And you have to include your iOS stream, okay? If you don't have that in there, it's not going to work. And if you're going to use your fixed set precision because you're playing with the floats and you want to be able to set that precision, you're going to need iomanip. Now, I'm not going to tell you how to use these things, but I just want you to know they're there and you're going to need to know those later on. But if you just want to play around, cout, make your arrow operators point towards your cout, and then put whatever your variable name is right there. Now, if you want it to say something so you know, oh, this is what I'm printing out, you can add a string. And we add a string with double quotations. And I'm going to say int is, make sure you put a space, and then another arrow operator there, and then I'm going to put I. Let's see what it does for us. As you can see, it gets our string out and shows us our variable. Thank you for tuning in to BTK and for allowing me to teach a little bit about bits, bytes, and data types. I hope you found this video somewhat useful. If so, please remember to like and subscribe. Until next time.